This is my educational story. I want to start off by saying I absolutely hated school when I was young. Even in second grade, you could ask my grandma because I got in a lot of trouble. I was more interested about nature and about this world because the little tadpoles swimming around and the frogs in the ponds, they were more curious to me than school. Multiple times after recess or after lunch break, I would just go to this pond in school and I'd take off my shirt and everything. I would go in there, take my shoes, and catch these tadpoles and little critters that I found. And 5 minutes before the bell rang to tell us that the school's over, I would come back to the classroom just drenched in mud and all this yuckiness. But yet, I have a shoe full of tadpoles. That's how much I cared about school. And in middle school, I didn't really like it too much because it's mainly all kind of like formulas that you had to remember, and then you're writing stuff, and we have PE and stuff like that. It's good to interact with kids. But high school, I thought high school was going to be absolutely awesome because throughout middle school I had questions, and then high school I wanted those questions to be answered. Because I knew that in high school we could take physics, we could take chemistry, we could take biology, we could take all these cool sounding classes. I was really, really happy. So my freshman year of high school, I took what was like Introduction to Sciences or something like that. It's supposed to encompass a little bit of physics, a little bit of chemistry, and on that first day of class, I raised my hand. I'm like, "Teacher, I have a burning question." And she's like, "Okay, go ahead." So I asked, "What is gravity?" As soon as I closed my mouth, I hear laughter from this side, a whole bunch of laughter from this side, and now at this point my hands are sweaty. I'm like, "Well, what did I do? Did I say something stupid? Did I say something wrong?" And I'm just being super flustered right now, and the teacher kind of laughs along with the students and says, "Well, what do you mean?" I'm like, "Well, I dropped this pencil, right? And then it falls to the ground. Why does it fall on the ground?" And she basically just says, "It's gravity." And then all the people around me are laughing because I'm asking this question. And so from that experience, I had to be a little bit more reserved to myself. I had to keep questions to myself because I didn't want to experience the same thing again, right? It was kind of frightening, to be honest, when I was a kid. And then it was, let's see, biology, no, chemistry. I asked the question, "What is fire?" I'm like, "What is fire, teacher? It's burning. I see it. I could put a Bunsen burner on, and I could put that little match, and it's gonna fire. I got fire. Well, what is that fire?" And the teacher kind of gives me this dumb look. "Well, fire is fire," and then kind of leaves it at that. I'm like, "Well, okay, here we go again." I'm being kind of pushed aside, and no one's taking my question seriously. And then I go to physics. Now, physics was great. I asked the question, "What's a magnet?" And then I was at least able to get an answer of wrapping of the wire, and then having an iron core and being able to make a north and south pole. I was like, "Oh, cool, right." But I was more intrigued about the permanent magnets, or now those are made industrially like that. However, I was more interested in actually the natural magnets and how they got their the polarity charges themselves in nature. And so throughout high school, I was really kind of not bored, but I wasn't motivated to do anything because my questions weren't being answered. I felt reserved all the time because I thought I was asking stupid questions, and especially mathematics. I hated math at that time. I absolutely did. We have equations like pi r squared, or even pi. We were supposed to memorize it as 3.14159 or something like that, of that sort, right? But in reality, it's just circumference over diameter, right? But the teacher never goes over that. It's like, just remember it, and then remember what else did we have? We had radians, and we had different polar coordinates or Cartesian coordinates, and we had to use those two together and go one to one. and we had all these graphs that we had to remember as well, and how we could graph them. I was super bored. I was like, well, how is this even applicable to anything that I want to do? We were just crunching numbers, essentially. So I didn't have any fun. However, the only good part that I learned in high school was from the junior ROTC program that they had. Math Sergeant taught me how important it is, and he was a role model for me because he was one of the friendliest and nicest guys that I've ever met. And he taught me that being friendly and kind to others, but being strict to yourself to improve yourself, is very important. And that is one of the biggest morals that I believe in. And I'm so glad I had him as my instructor, because now my 4 years of high school that I thought was wasted wasn't wasted. Moving forward, after I graduated high school, I wanted to become a police officer. I wanted to become a police officer because I wanted to serve my country, I guess, but more so my neighborhood, be in the country and be able to protect the loved ones. I thought there couldn't be any better job than that. So I thought I needed to get a degree to become a good police officer, right? But then I found out about the Coast Guard Academy and how the Coast Guard could pay for my college and give me such great education. But I applied for it, but I didn't get accepted to the Coast Guard Academy, so I wanted to go back to my police officer route. So I did. I applied for Wazoo. I got accepted, but financially at that time, because I wanted to be a police officer, it didn't weigh too much. You know, if it was like, I don't know, $50,000-$60,000 for me a year to get this education just to become a police officer, didn't really weigh too well. So I kid you guys not, the day of the last day of UW Bothell taking in applications, I applied for it. And at this time, I was only able to type with my two fingers like this, and I typed it all in caps to get their attention, and I'm making the silliest grammatical errors. I still do, and spelling errors. I'm so surprised I was able to be accepted. I said something along the lines of, I have literally nowhere to go because financially I can't really go to Wazoo, and I didn't apply anywhere else. I got rejected from the Coast Guard Academy, and then I told them that I would work hard in their college, and so I sent that in, and I was baffled when I opened the letter that when they told me that I got accepted to UW Bothell. I was like, wow, how am I able to go to such a wonderful school? I was truly, I felt blessed to be able to go to that school. And from there on, I started the journey from taking algebra. I took algebra because I thought I wanted to, at least get like a business degree or something that would help out for me being a police officer. I just wanted to get a degree. That was my main focus. So I did mathematics, or I did algebra, right? And it was the first 4.0 that I got. I was so happy. I was like, oh, well, maybe math is for me. So I took algebra, I took pre-cal, and then I took everything up until ST Math 390. That's probability and statistics for engineering and sciences. This was a great class, but throughout the time, especially linear algebra, or we had matrix algebra, which is pretty much linear algebra, and differential equations. I was like, wow, these are very cool concepts, but how are we supposed to use it? Especially Euler's identity. It's an amazing formula, but I had no idea how to use it. We were taught that equation, but no practical use of it. And then we had linear algebra, which is fun, especially in the computer sciences, being able to do matrices fast, very, very useful. But I didn't understand where and how cross products came to be, or why cross product is so important. I didn't really fully understand why we had all these vector computations and all these 3D and 3 integrals, triple integrals and double integral kind of stuff. Just didn't really fully comprehend all of that. Like, I could do it, and it's fun, but I didn't get it. But it was different from high school, because in high school, we don't know any of the proofs. Like I said, we don't know where pi came from. And in college, actually, they don't go over all the proofs. They kind of hint at the proofs or the derivations of the formulas. But because I had a lot more time in college, like a lot more time compared to having 6 classes in high school, or 6 or 7 periods, right? And then having to learn all these different topics. My head's like, here. We have history, we've got math, we've got science. Like, how am I supposed to focus, right? But instead, in college, I was able to focus on one main thing, and that for me at the time was mathematics. All the extra time that I had, I spent in deriving and proving each equation. So whether it be when I took calculus, it was like we have product rule, we have exponential rules, logarithmic rules, and we have like a bunch of integral rules. Using the extra time that I had, I was able to derive and prove, and I had an extremely fun time doing that, being able to see that proof and derivation, so that when tests came, I didn't even have to memorize it. I could just, oh, the proof is this, and so I'll just write down the proof on the side, and I'm like, okay, I'll use this equation, and boom, there you have it. I loved it. But, like I said, it didn't explain to me the use of cross products, or the use of Euler's identity. So I was like, oh, how about I take some more physics classes? Maybe physics can teach me a lot of that. But at that time, I had 2 jobs, right? You could say one job was at the gun range. I worked roughly like 24 hours, 25 hours a week, something like that. And then I had my job, kind of like helping out my parents here. We have a lot of land, so I was mowing the lawn, moving stuff around, getting stuff built. So that took my whole weekends off. So even though physics was very fun, just really wasn't for me at the time, because I didn't have enough time to derive and prove and all the equations in the book. And for me, the derivation was everything. If I didn't know where it came from, I didn't really care much to learn about it. I loved physics. It was a lot of fun, but like I said, I didn't have too much time to engross myself into it. But I did enjoy physics, especially learning about lights and optics. That was one of my favorite parts of physics. But it didn't explain to me how things were made, how things were engineered, and as well as I just wasn't too intrigued in calculating the elliptical orbits of planets and stars. It just wasn't my forte. I'm like, if I can't see it, why should I do it? It's kind of going back to high school. It's like, why am I using all these equations if I don't really know the applicability of it? So physics and math were kind of in the same category for me, where I was like, I just can't see it yet. But then I took engineering classes. This was it. When I took statics, it taught me about balancing out forces. I'm like, oh, okay, so this is why things are made like this. And then when I took deformable bodies, I understand why things are breaking and why we should be worried about stuff. And then when I took dynamics, I was like, oh, okay, if we have something that's accelerating, it's going to break more because we have more forces on it. And when I took material science, it taught me molecularly how things are breaking and how things are working and how they're manufactured. But these 3 are one of my favorite classes that I took in engineering. We have thermodynamics, fluid mechanics, and heat transfer. These 3 are the biggest theoretical classes that you would take. Thermodynamics has entropy. We have the two big thermodynamic laws, and we have fluid mechanics, where it shows us about how fluids like air are going past objects, like could be an airplane wing or cars, and we can see how much drag forces it has. And we have heat transfer. Heat transfer being like how much heat is actually conducting through things, and how having temperature differences are going to affect all that. And with these three, as well as one of my favorite, this here is one of my favorite books. It's Mechanical Engineering Design, because this right here is like history. I say that because engineers, they make something, right? And then if it breaks, they record it. And so in here we have, I believe up to like chapter 6, everything in here is derivable, which is great, fun for me, something I like. But after chapter 6, a lot of these formulas are actually coming from experimental data, and that's history in itself. So if something breaks, we record it, and we keep on doing those testing. And so now using that data, we could come up with equations. So that's why some of these equations are from chapter 1 through 6 are the basic ones, and then you add on certain parameters to it to make that function better. So not all of them are derivable, and I wouldn't derive them because they come from logarithmic graphs and charts. And so although you can see the idea and concept of it, a lot of it is best fit, line of best fit. So that is one of my favorite ones. So now that I took thermodynamics, fluid mechanics, and heat transfer and machine design, now we can start to build instruments to see stuff. You remember that Doppler effect kind of thing or the elliptical orbits of planets that I was talking about earlier? With these 4 classes, now we can start to design instruments and rockets or things that would enable us to be out there to see it. And that's what I wanted. I wanted to, if I could see it, I could wrap my head around it, right? If I could see and observe things, then I'm like, oh, I see a point in it. And that's why I really enjoy these. If Galileo didn't have a telescope, he wouldn't be able to make the observations that he was making, right? Or if Kepler didn't have a telescope as well, right? And without those instruments, we can't observe. And so being able to engineer something to enable us to go into space, to get the data that we want to get, because without data we can't create formulas, right? And we could always theorize, but we can't always finalize it if we don't have that data or that instrument. And so that's why I love these. However, these 3 books, or 4 books, didn't explain to me the idea of gravity, and so I'm still very, very curious about gravity and how different universes might exist, like parallel universes. And so what I do in my free time is, here's a book that I have lying around here. I read scientific journals or articles, and as well as some books. This one right here is just one that I have laying around. It's just Einstein's Theory of Relativity by Max Born. This is a really good book to derive and prove fundamental equations, as well as Maxwell's laws and space-time, as well as E equals mc squared. So that's a lot of fun. And then I like listening to Dr. Kaku's interviews as well. I think they're so fascinating, and I ordered some books from them, so I hope to read that as well. And so what I find is that now that I understand the basics, I could go into and learn and appreciate more of the bigger questions. And so with these actually, we have an understanding of more of the fundamentals. But every time I do a calculation, it makes me think. These engineering problems really get me to question the basics of things out there. It could be as simple as what's a force or what's a torque, right? A lot of people just kind of ignore those, but because I was able to use the time and kind of derive and really think and picture what's going on in each problem, it enables me to really think about the fundamentals of this universe. And through that, I have a lot of fun. And so being able to think kind of basically helps me to question the universe more basically in a fundamental level. And that's what I love to do. That's why I read books, like I said, the one that I have here, the Einstein Theory of Relativity, or Dr. Kaku's Theoretical Physics. I love to hear about that, and as well as read about that. It just keeps on connecting the dots. I love every single aspect. So what do I want to say? I want to say that pick any major and have a lot of fun, but make sure it's the major that you want to do. It took me a while to find out which major I want to do for sure. And just because you might be good at math from middle school or high school, I would say really make your decisions correctly, because if you're not really having fun doing math, like deriving stuff or proving stuff, then you're not going to have a lot of fun in college, and it's not going to fuel your curiosity. And one more thing, I like to say that whenever a kid approaches you and asks you a simple question, whether it be why can't I run faster than light, what is light, or why doesn't light accelerate, please don't just brush it off, because they're asking it because they're curious about it and they want to learn more about it, as well as it's something that they observed, or it's something that is very fundamental, and fundamentals are everything in this universe, right? And so if we take those questions and actually fully be able to explain that to a child, then we know more about it. Thank you so much for watching.